Okay, so today's fairly short class. We're going to do the last concept today is secant, cosecant, and cotangent graphs and what they look like. So basically, we're going to look at secant and cosecant first because they're the easiest ones to do. And there's basically one thing to remember. Okay, it's not on our unit circle, but it is a reciprocal of a trig identity that is on your unit circle. So you can always use the original trig identity, or trig primary function, sine, cosine, and do that first, and then you can get the cosine or cosecant and secant graph from it. So basically the one concept that we need is simply this, that the cosecant graph is placed on top of the sine graph, and we'll put that in quotation marks. And likely the secant graph is placed on top of the cosine graph. Okay, so it looks something like this. So the key point that I always remember, how I remember it, is you have this, I just do the saying U's on hills. If you can remember that, U's on hills, you just put a U on top of a hill. Okay, so let's do the cosecant graph first. So we're going to do y equals cosine secant x. Y equals cosecant x. Okay, so step one, sketch the sine graph. In pencil, we'll say. Okay, so let's do that first. Look at my marker here. Okay, so I'm going to take I'll slide this up, and we're just going to do a rough graph of, cosecant x, not c. There we go. Okay, so make an axis. Okay, and then on the axis, we're going to put 0, 90, 180, 270, and 360. Okay, and then we know that the sine and cosine graph go up to 1 and -1 down. Okay, so the first thing we're going to do is just sketch the sine graph, and I'll do that in green here, just lightly. So there's the sine graph, right there. So we just oh man, kind of miss a dot. Okay, there's the sine graph. It's supposed to be even, but mine's a little off or whatever. Okay, so that's y equals sine x. Okay, that's step one. Step two is to wherever the graph has a y-intercept, draw an asymptote. So step two, we'll do that next here. I'll type it here. So step two, draw asymptotes. Oops, I can't spell it. I think I missed a letter there. Draw asymptotes where the sine graph touches the x-axis. Okay, so I'm going to take my ruler, or in this case a straight line tool, and I'm going to just make dotted lines wherever it touches it here. So that's right here at 180. Oops, that's not dotted. Make it dotted. At 180. Okay, and then 360. And then 0, I guess, would be the other one. It's hard to see there. I'll maybe have to use a different color there. Okay, so there's the asymptotes. And then the final thing, all we do now to get the cosecant graph is to draw a U on top of a hill. So wherever there's a hill, you draw a U now. So step 3, which we'll do, I'll write underneath here. And we'll use blue for that. We're going to draw a U on top of a hill, or a like this. So just barely touch the max, and then go towards the asymptote and draw a U. This one's upside down, this one's upright. So there's one period. So step 3, draw a U on a hill. Okay, and this is y equals cosecant. Cosecant x. And that's as simple as that. All you have to do is draw, and then you could erase the green part, and then the blue would only be the cosecant graph. Now, if you did it in Desmos, you wouldn't see the asymptotes, but you'd see the two U's. Okay? Okay, it still has the properties of the cosecant graph. It has no maximum or min. Okay, so cosecant graph. Okay? No max or min. Okay, because it goes on forever, right? Down and up, like you can say negative infinity, infinity if you want. And then you can see that there's asymptotes. Okay, so we could say that there's asymptotes at 0 degrees, 180 degrees, and 360. And then we keep on, and then you just go, and every 360 after that. Okay, if you keep on going, right? So if you add 360 to 180 or 360 to 360, there'd be asymptotes there, okay? And the period is, it repeats itself. Okay, now it repeats every 360 degrees because it's one up U and one down U. One up U, one down U. So this would be an up U, down U, up U, down U. Okay, so period is 360 degrees. Okay, of course you could do it in radians and just use 0, pi over 2, pi, 3 pi over 2, and 2 pi as well. So that's the first one. Okay, the second thing that we're going to look at is the same thing if you had the secant graph. Okay, so the secant graph is related to cosine. Okay, so let's do that one on the second page. So same process for the secant graph. Okay, so we're going to do y equals secant x. Okay, so we're going to do the same thing we did, the 3 steps. First thing we're going to do is draw a graph setup. Okay, and then we're going to have 0, 0, 90, 180, 270, and 360. Okay, now with the cosine graph, we know that it goes up to 1, 0, and then -1. Okay, now with the cosine graph, it's a different shape. So we start here. And we finish back up here again. So it's like this. Okay, that's our y equals cosine graph. Okay, now if we follow the same rule, we put our asymptotes in where it touches the x-axis. That's 90 and 270. So we take our, and just do a straight line here. Okay, I kind of missed the 90 there. Let me do that again. Right there. Okay, and then we just draw our U's on the hills here. Now, we're only going to have half a U here. I guess it's in blue that I'm using here. Like that. Okay, and then half a U here. And then, of course, half a U here. So that's what the y equals secant graph looks like. And that's basically it. Now with the cotan graph, it's the exact same thing as a tan graph, except it's flipped. Okay? So the summary on this one here, we can say, okay, so again with y equals secant x, there's no max or min. Or if you like, you can say infinity and negative infinity because it goes up. Okay? And then it's asymptotes. Okay, they're at 90 degrees and 270 plus 360 as you go around, right? 360, 360, 360 as you go, plus 360n if you like. Okay, and then of course, the period is still 360 degrees. Okay, so it's very similar to the cosecant graph. Okay, now to do the cotan graph, we're just going to do it on Desmos because it's pretty, well, we could graph it out like we did the tangent graph, but we did that with the tangent graph. We're just going to do it quickly to compare the two. The cotan graph is basically the curvature is flipped over to what the tan graph is. So if I bring over here, and we'll just do it on Desmos here to look at it. So we're going to go with Desmos. Okay, and we'll set it up so that we're in degrees, and we'll go from, we'll do a couple of them. We'll go negative 360 to positive 360. Okay, and then we'll do negative 6 to positive 6 works out okay. Okay, so let's do y equals tan x. Okay, and then we'll do the cotan beside it. Okay, so basically everything is shifted over. Okay, so instead of being at 90 degrees there, you're at 0 and 180. And it basically curves the other way. Okay. So tangent, it's 90 and 270 where it hits. And cotangent has an asymptote at negative 90 and positive 90, and also at 270. Okay, so they're just kind of flipped over of each other. Okay, so we'll do a little sketch of that on our summary here. So cotan x y equals cotan x. Okay. Okay, and basically this is shifted over. Shifts over from the tan graph and curves the other way. Okay, so what does it look like when we graph it? If we just do the positive just though 0 to 360. $90, $180, $270, $360. Okay, so with the cotan graph, our intersection points are at 90 and 270. Okay, our asymptotes are 180, 0, and 360. Let's use a straight line tool for that. So, got our asymptote there, and one here, and one here. Okay, and where the tangent graph would curve to the left, this one's curving the other way. So we would start at the 90-degree line, and we would go up towards 0 and down towards 180. So it looks like this. Okay, we'll do, oh, let's make it. Like that, and then this one will go like that, and then this one would go at the 270 mark, you'd go up towards 180 again. And then down. So if we're doing the tan graph, it would be connecting here at the 180 mark and the 0 mark and curving differently. Okay. Okay, and that's the 3 reciprocal identities. Now we don't do a lot with them. Okay, we transforming them. You basically, if you're going to do a transformed one, you just draw the transformed sine or cosine graph and then draw it on top of it. We'll do one example of that, and that'll be it for today. Okay, and that'll be it for the unit. Now, in terms of the assignment, in this section, there are no transform. Well, let me just make sure I'm not lying to you. I'll just double check here. Let's see what it looks like here. Okay, in terms of the assignment here. Yeah, okay, there's no transformed one, so we're not going to bother with it then. I'm not going to add extra on your plate. I'll just stop there. So that is it for today. Okay, I will post up the hand-in. Okay, I handed back your assignments there. I'll post the number 2 hand-in up, and that's what we'll work on tomorrow. If you want to get started on it early, you can do it today, but if you'd rather not, that's fine too. I'm going to post it up here in about 5 minutes. I'll print it off for you guys, and then we'll be working on it tomorrow. All right? So that's basically it. We're done the first unit now. So that means we got hand-in number 2, and then we'll do an exam outline after that, and then we'll do the quiz sometime this week in math. Okay? I think everybody's handed their assignment in. I think the only one I have to mark is Danny's, and then everybody's in the right split because I got Jake's here. So, all right, that's it for today. We will see you guys on Tuesday.
Okay. When are we supposed to have that meeting?